Hey, it's Doc Williams, and in this video, we will predict the products of a double displacement reaction and then balance that chemical equation. When dealing with polyatomic ions, we're going to treat the polyatomic ion as a single element. That means that this compound will be a B, A for the barium, B for the hydroxide, plus a compound of CD, C for the hydrogen, and D for the nitrate. So I'm going to get rid of these arrows so that I can use my full method from math. Our first barium is going to form a new compound with the last, which is nitrate, and our two inside elements will form a new compound. Now remember, when we're doing anything where we're combining metals and nonmetals, we have to make sure that the charges equal zero. So I'm going to come over here to the side and work on barium and nitrate. Barium has a charge of +2 because it's in group 2, and nitrate has a charge of -1. So the ionic charge of barium becomes the subscript for my nitrate, and the charge for nitrate becomes the subscript for my barium. Barium 1, we do not have to write that, but whenever we have multiple polyatomic ions, we enclose those in parentheses and then write the subscript behind the parentheses. This will means that we have two, which is two complete molecules of the polyatomic ion. I'm going to keep this in this color so that we see where this is coming from. Next, we have a hydroxide and a hydrogen. And when we have a hydrogen plus a hydroxide, we are forming water. Now that we have our products, let's balance the chemical equation. The first thing I want to point out about this chemical equation is that we have a polyatomic ion here, but we do not see that same polyatomic ion in the product side. So that means that when we're listing, we're going to separate the oxygen and the hydrogens and count them individually to account for them on the product side. However, we see that we have a nitrate in the reactants and the same polyatomic ion intact on the product. So we're going to treat that the same. It will help us when we are balancing the chemical equation. So now let's make our tally. We have barium on our reactants and barium in the products. Within the parentheses, we have the polyatomic ion of hydroxide, but we do not see that polyatomic ion intact in the products. So that means we're going to have to list our oxygen and hydrogen out on both sides so that we can account for each of these atoms. We have hydrogen in our nitric acid, which is already tallied and listed. We don't have to list it again. And we have a nitrate ion in our reactants, and we see it intact on our products. So we can list these together. It looks crazy. It feels funny if you've been doing these for a while, but this makes it easier when we are balancing the entire equation. So let's go and make our tally. We have one barium. We will distribute this to each of the atoms inside the parentheses. So 2 times the subscript of 1 for the oxygen gives us 2 oxygens. 2 times the subscript of 1 for the hydrogen gives us 2, plus the 1 for the nitric acid gives us 3 hydrogens. And we have 1 nitrate. Tallying up on our product side, we have 1 barium. We have 2 nitrates because 2 times this entire thing inside gives us 2. Now remember, we have accounted for the nitrogen and the oxygen inside of the nitrate, so we don't have to list that separately or account for what's inside of this parentheses a second time. It's already counted for there. So for the water, we have 1 oxygen and 2 hydrogens. The first thing I'm going to balance will be the polyatomic ions of the nitrates. So I have 2 on my product side. If I add a 2 here, then that means I have 2 nitrates, they're balanced, and now I need to update my hydrogens. So the 2 hydrogens within the barium hydroxide plus the 2 hydrogens here in the nitric acid gives me 4 hydrogens. My next step, since I have 4 hydrogens on one side and 2 on the other, I'm going to go ahead and balance the hydrogens on my products by adding a coefficient of 2 in front of water, which will change that hydrogens from 2 to 4, and it will also change my oxygens to 2. The good thing about doing that is that it balanced the oxygens on both sides. The baryons are already balanced. So the balanced chemical equation, to write this again down here for more clarity, we have barium hydroxide plus 2 nitric acids gives you 1 barium nitrate plus 2 waters. And that is our new balanced chemical equation. As always, thank you for watching.